I had somebody ask about number 5 here from exercise 7i. So we're looking at a integral, and nothing's really jumping out at first sight. So this is going to be one of those exciting videos where I'm not sure how we're going to do this. All right, so let's try this. Okay, so when I look at this one, I don't see an obvious substitution. I don't see a square root of anything plus anything. I don't see an obvious triangle. I'm going to try a u substitution. Let's try u equals 2x minus 1. So then du would be 2 dx. And it's not going to cancel anything else out, but I could express u plus 1 over 2 as x. And then I'm able to rewrite my integral all in terms of u. So this tells me that du over 2 is dx. So let's rewrite it all. So we get 16 times x, so u plus 1 over 2, to the fourth. Dx is du over 2, and the denominator is u squared. So that's great. And then the idea I have here is that I haven't talked about this much in class, but you can take your bounds of integration from 1 to 2 and express those in terms of u. So u is 2 times x minus 1, so I go 2 times 1 minus 1. That gives me a bound of 1. And then I go 2 times 2 minus 1. That gives me a bound of 3. So now everything's in terms of u. You could also just back substitute to x and use the original bounds if you want to do that way. Okay, so now let's look at what we've got. 16 here and 2 to the fourth cancel out. 2 to the fourth is equal to 16. So I can go cancel those out. And then I'm going to just expand out the top. So we get u to the fourth plus 4u cubed plus 6u squared plus 4u plus 1. I just thought about Pascal's triangle. This is all I did here. I know that the fourth power follows the 1, 4, 6, 4, 1 pattern of that. I still have this extra 2 here, so let's bring that guy out here. And I still have a u squared on the bottom and a du. So then I get 1/2 integral from 1 to 3. I'm going to divide each term by u squared, and then integrate. So we get 1/2 times 1/3 u cubed plus 4u squared over 2 plus 6u plus 4 natural log absolute value of u plus u to the negative 1 over negative 1 evaluated from 1 to 3. It's going to be kind of dumb to see me try and do this all by hand, but that's what we're going to do. So we have 1/2. I'm going to plug in 3 to everything. So 1/3 times 27 plus 2 times 9 plus 6 times 3 plus 4 natural log 3 minus 1/3. All of this minus plugging in 1/3 plus 2 plus 6. Natural log of 1 is 0. Yes. Minus 1. Okay, so I don't think this is going to come out to be anything, particularly enlightening, but we get, so let's see, this is 9 plus 18 is 27, plus another 18 is 37, 45. So we have 45 minus 1/3 is 44 2/3 plus 4 natural log of 3 minus, does this come out to be 8, 7, 7 2/3. Okay, so yeah, whatever this comes out to be is the answer. The important thing about this is that when you have a linear term in your denominator, that this substitution right here allows you to create a linear term in your numerator. And if you can expand it out, then you can divide each term, one term at a time, to make it into something that is polynomial-ish. And then you can integrate each term by term. So there you go. Please let me know in the comments or send me an email if there's anything I can do to help.